All right, take out. I gave you that Frappy yesterday, but then we didn't get to it in the class area.
I'm so glad you're calling me safe. Probably sick. That was going to restart.
Okay, so I want to go through part of this together, and then we're going to do like the whole big process again on the back. We've kind of like taken apart a couple things, and I want to get back to like, okay, can we do the process again? So the assumptions that are necessary. That's just saying what are the conditions. So they're not even saying. You guys with me?
Yes.
They're not even saying in part A, like, tell whether they're true or not. They're just saying, like, what exists. In part B, they say tell whether they're satisfied in this situation. So what assumption or what conditions, assumptions, whatever, are necessary in general? Kind of. That's one of the things, right? Okay, so the summary of those is the sampling distribution has to be what? Approximately normal. Or you can put like T distribution, that's approximately normal. It's kind of the same idea. And then there's three ways that condition can be met, and that's what they're asking about, like in part B, like which one of those applies. All right, what else? Yeah. One thing here yesterday. You got it. Randomness, and then one other. Independence. Wait, you weren't here yesterday, right? Yeah. Alright, so then part B discuss whether they're satisfied in this situation. So sampling distribution is approximately normal. Well, there's three ways that could happen. Let's go through those three ways. Give me one way that could happen. Sample size is bigger than 30. That's one of the ways that condition can be met. Do we have that? We do not. What else is there? That's for independence. Yeah. Box plot or like a little sketch or something has to be approximately normal. I'm not going to jump to that yet because I don't want to like look into that unless I have to. You know, I don't want to just make a dot plot unless there's a reason for it. What's the other one that we're missing? What's the that one is approximately normal? Population. So if the population is approximately normal, that covers it. Does it say that? It does not. So then, this is interesting. We're not gonna be able to. Well, we're gonna have to like try to cheat this a little bit. So is that first condition met? So then we gotta go. Okay, now I gotta look. I don't have a normal population. I don't have a big enough sample size. So then I gotta look at what I do have and try to determine if what I do have is approximately normal. Well, what I looked at, the first thing I looked at there, if the data is approximately normal, what's going to be true about the mean and the median? It should be the same, or like at least really close, right? They're not going to be identical, but that's pretty far away. So I'm going to say that condition is not met. So sampling distribution is not approximately normal. And then you gotta like tell them why. So we don't have a normal population. We don't have a large enough sample size. And we don't have an approximately normal sample. What about independence? Do you think we're independent here? I think each footprint is independent. Well, I think you could probably make a case that they're not. If you were to like, yeah,
two feet from the same person.
or like a family, and they're all like really tall or something. So I think you could argue either way here as long as you backed it up. As far as the random or the independence piece, so I'm going to say. So you can do either. You can roll whatever you want here. Sample is not independent because the people in this cave might have something in common. Like it might not be a true random sample, you know. There might be like maybe it's a really small cave and it's all like Mr. Packer and his family went in there. Maybe it's a really big cave and I took them. I mean, it could be something about the cave that tends to draw tall or short people or something. So I'm going to say sample not independent. I think if you want to argue that it was independent, you can make that case too. That's not the part they're trying to get at. They're trying to get at this first part. And then is there randomness? There is randomness. So that part's okay. But the other, especially the first condition, is the one that they really want to get at there. We are going to do something a little different. We are going to change that 20. So we're going to go to the back and we're going to do the problem, like do the whole process. But we're kind of stuck because our conditions aren't met, right? So I'm going to fix that by just saying, okay, it is 40. So your sample size is 40 now. So now have we met the conditions? Now we're good. So we're going to flip it over and we're going to go through that whole template. So then I'm going to template out to like have next to you while we're going through it. It's up to you. First thing I do is label the test. So you have to label what type of test you're doing. I'm doing a T interval. Why did I choose T? Because we're doing means. We haven't gotten to proportions yet, but when we do proportions, that's Z. And what does interval mean? I'm trying to get like my estimate, like my parentheses from this to this, right? First thing we say is what mu is. Mu is what we are trying to find. And mu represents what level, population or sample? Population. So I want, mu is going to be the true population mean, and then I got to look and see what I forgot what is this, like length of the footprint? Yeah, true population mean, foot length. So I've got these 20 footprints. I want to use that to try to do. I can't go survey the other people because it was years ago and they're all done and decayed and stuff. So I'm gonna have to stick with these 20. Make my best guess. What's the next thing I do in the template? What's the statement? So we want to estimate mu. So estimate and interval always go together. That's what an interval is. It's an estimate. So we want to estimate mu at a 95. 95% confidence level. So that'd be the end of like your first box if you were doing. If you're looking at that template, there's the name and then there's the first box. The second box is conditions. So we had written down for like RIT here. So what's R stand for? Randomness. That's stated, right? Randomly selected. So the problem states random. So that checks off that box. What's I stand for? I stands for independence, and whether or not the footprints are independent, I kind of discussed both sides, right? So I'm going to go with the other one, because that one's a little iffy, so I'm not quite sure I can say each footprint's independent, so I'm going to use the 10% thing. If you think 20, so I is independence. Oh yeah. So is 40 less than 10% of all the footprints that have ever been? Probably. So you can do that. 40 is less than 10% of, I guess that's all footprints in the cave. But there's really probably nothing wrong with the other thing. The other thing would be saying each footprint is independent. I'm just not quite sure that's true, so I'm choosing the other road, you know. It's like when I don't know how to spell a word and I'm writing paper, so I just choose a different word instead of actually figuring out the word. Alright, T stands for T distribution, which is the same idea as the sampling distribution is normal. You don't have to write all that, I'm just doing it to help you remember it. And this is one of those three things, and what do we have here to validate that one? N is greater than or equal to 30. That's the one, if we didn't have that, we might be kind of stuck. Am I going too fast, or are we good? Alright, any questions?
We need to write all of this out first.
I have to write all of this out. And the worst news is, so we do two kinds of things. We do confidence intervals and we do tests. Like, here's a claim, let's test if it's statistically valid or not. These are the shorter write-ups. yeah.
So they have to like meet all the requirements for RIT to work.
Yeah.
To do the problem.
Yeah. But almost always they're going to work because they want you to do the problem. You know? If it doesn't work, it's usually something like this, where you can kind of tell, like, oh, they didn't tell me to do the problem, so there must be something like. All right, the next box is the math box, right? So we write it out 4 times. What's the first one we write it out? Words, symbols, numbers, and then the answer. So in words, the statistic plus or minus the critical value. The good news about, like, these are long. The good news of that is there'll be like 1 or 2 on your test. You know, I can't give you 10 of these. Plus or minus critical value times what?
Standard deviation.
Standard deviation of the statistic. And that formula is on your formula sheet. I think you'll have it memorized because you do it so much, but just in case. So that's words. And symbols. What's the symbol for the statistic and where it means? X bar. Plus or minus. Your critical value is always T star or Z star. I kind of look up and, okay, I'm in a T interval, so it's probably T star. And then the standard deviation divided by the square root of it. Right? Good there? X bar. Is that mean or median? Because they gave you both. It's mean, right? So X bar is 24.8. T star. How do I find T star? Inverse T, 1.95 divided by 2. Degrees of freedom is 39, or 40 minus 1 if you want the calculator to do that part. That's cool.
I actually do this so I don't get distracted.
Oh, that's right. That makes sense. Yeah. Right. I'm just joking. So 2.027-ish. Make sure you get the same things be there. That might validate my number. 2.023. 0226. Yeah, I got a little excited with the rounding. 023. Alright. Times, and then the standard deviation, 7.5 divided by the square root of 40. And then you are welcome to calculate that. So my claim was that calculating it would be slower. So like you could figure this out, get your math, and say this comes out to 2. Say, oh, this comes out to 2. Then you would go 24.8 plus 2, 24.8 minus 2. I think that takes longer. I think I'm more likely to screw it up and try to do it by hand. So I just use a calculator. Type it in and see what the calculator says. You're welcome to do it by hand, though. While I was going through this whole speech yesterday about how this takes so much longer, somebody in class did the math. They were like, well, I finished that for you. You finished talking about the other one. So it's whatever. It's whatever. I don't care which way you want to do it. I just want to make sure you get the right answer. But I'm going to go stat, tests, t-interval. Type in the information. So X bar is 24.8. Standard deviation is 7.5. And it's 40. So I get 22.4 and 27.2. Confirm? Anybody? You got it? Okay. Questions on getting that number? Everybody there?
You have to round.
If you want to put more decimals, it's not going to be wrong. Like if you're ever in doubt, just keep putting more and more and more. There's someone 2 years ago that refused to round, so I get like 10 decimals for every single answer, every single test, every single question. But whatever, it's not wrong. Any other questions on this box here? Alright, and then the last one is our conclusion. So we are 95% confident that what? What was the whole point of this? What were we trying to estimate? We're trying to estimate mu, which is the population mean, right? So based off these 20 footprints that we found, I'm trying to make a guess about like this historic population or whatever it was. So we are 95% confident that mu is between 22.4 and 27.2. So that he asked if we have to put context. We did put context. That's the point of identifying what mu is up here. So like I said what mu is in the with context, and then from then on I can just use mu and it's got like context built in. There is one more thing here. We should go over here and say degrees of freedom equals 39. I do want to write that on there. Other than that, Abby, what's up?
Are they never gonna ask like what the width is and stuff like that?
No, those would be, that wouldn't be a free response. That'd be like a multiple choice. I was just going to talk about that though. So go ahead and find the width. Let's do this. So we're done with this problem. You would not have to do this on a free response, but just to practice what we practiced yesterday, I want you to find the width, the point estimate, the margin of error, and one more thing. Oh, write it like blank plus or minus blank. Again, this is not part of this problem. I'm like moving on. Like, okay, let's review this from yesterday. So these are long. I get that, but there's a couple things. One is the free response questions, so like we have to do it. The second thing is we're covering. There's so much material in this. So when you guys get to the multiple choice, I think a lot of them you'll just be like, oh yeah, that's part of this process. That's part of this process. Like we're covering a lot of ground in this. Plus we have to do it anyway. So it is what it is. So did you guys get 4.8 for the width?
Yeah.
How am I getting that? Sorry. How am I getting that? Just subtracting, right? The point estimate, you can do it two ways. If you only had the interval, like let's say you didn't even know this, you only have the interval, what does the 24.8 have to do with those two numbers? It's in the middle, it's the average. Or if you have that, you can just look at it. margin of error is half of the width, right? So 2.4. So if you want to write this the other way, it'd be 24.8 plus or minus 2.4. Questions anywhere in what we just did? Okay. Get a blank template sheet. If you have one, great. If not, they're on the podium. There's like 200 of them up there. We'll get through. Way more than that. I want you to write the problem on the back. Do it on the front. Right there. So if I were you, I'd write the problem on the back and do the work on the front. So then when you go to look at it later, oh, here's this problem here. What were we talking about? Oh yeah, I wrote it on the back. You can kind of refer back to the problem. first, most of it, I guess. But you can check what you got there. If you got a question, please ask. Check it carefully. Like, it's easy to kind of be a little lazy about it and just look and be like, oh yeah, I got the same math. But you're getting points for every single thing in here. So make sure you're checking for all the little details. What's that?
I know 1.5, but it might have just.
1.5 was the mean.
Oh, I might have written it twice. Yeah.
Is everybody okay on this top part? So I can make slide the paper to show the bottom part. Alright, how are you doing on this? Okay? Questions? How many are done? We're good? Okay. Anything I can help with? Alright, let's move on a little bit here. I want to start talking about T-star, like how T-star affects things. So I want you to find those things. We want to kind of talk about what's going on there. So just find T-star. Don't do any other calculations. Keep this 95%, and we're just changing this. And I want to know what happens when I change the sample size. What happens to T-star when I change the sample size? Getting the same numbers out. So what happens to T star as n gets bigger? T star gets smaller. That is what this drawing is supposed to kind of get at. But let's do something else first, though. Go back to, so the problem we just did, n was what, 100? And our interval was 1.4 to 1.6. I want you to figure out what our interval would have been if n were 2, 10, 500. But don't worry about this one. Actually, I could have just crossed out that one. So go back, like do your test again, but just change n. We good? We got these or not? I have to double look at what I got. Okay, so this is I'm trying to get to a point here. Increasing n makes T star what? Smaller. And the interval smaller. That makes sense, right? Like the more data we have, the more narrower our guess can be. But I want to talk about that chart on the side that I have on the board over there. I'll draw the notes in a second. But what's going on is when when my sample size is small, so like say I have n equals 2, I don't have any information. I really have very, very little. Okay, I'm trying to guess the average amount of money that people carry in their wallets at Milan High School. I randomly choose these two people, and I try to make an interval based on that. Well, I have 2 pieces of data. How accurate is that? It's terrible, right? So you get this really wide range because how much money do you have? 20 bucks. Okay, so that's 17.5 is my point estimate, right? But at this point, with 2 pieces of data, I gotta go, okay, it could go 100 this way, 100 this way. As I start collecting more data, what can I do with my estimate? I can start zeroing in, right? So when you don't have much data, you get this really spread out, not very flat, huge variance in our interval or in the distribution that we're using. As n gets bigger, so this is supposed to be a medium sample size, it starts to tighten a little bit. As we get larger, it starts to tighten a little bit. Eventually, if you had a large enough sample size, this is normal. It converges, it matches up eventually. So if we need to do the normal one, I don't know if you guys got that or not, but the normal distribution was 1.96. And you can see we're kind of trending towards that. So if I did n is 10,000, it would take a calculator a minute. And it would be pretty close to that number. So the bigger samples that we take, the closer we get to this ideal normal curve. Does that make some sense? So you might want to draw that in your notes. So I'll try to draw what I have on the board there. So like this is a small sample. T distribution. You can do it on separate graphs even. This is a good, I got a good idea. That was gonna be good. So what's happening as we progress down those graphs? What is N doing? N is increasing. So that's just another way, like that graph kind of looks confusing to me because it's just overlapping everywhere, dotted lines and stuff. This I think might make a little more sense. Good there? Alright, find each T star here. So I'm changing the confidence interval now.
Like for inverse norm T, or inverse T, do you put 1.5? That's what I do.
1.85 divided by 2,
Oh yeah.
and then 49. Or 50 minus 1. You get my numbers? Alright, so let me get to the point I'm trying to make. Some of you already know. You just like get to the freaking point, but deal with it. T star is after the plus minus sign, right? So if that number is bigger, I'm going to be adding or subtracting more to my point estimate. So if that number gets bigger, am I making my interval wider or narrower? I'm making my interval wider. So as that number gets bigger, so interval widens as we go down this list. We've talked about that with the like. So yesterday, remember I said, okay, I think maybe that's another class. I don't know. You got to guess tomorrow's high temperature. You got to be 100%. You got to give me an interval that contains tomorrow's high temperature. We talked about this yesterday.
Yeah.
If you're wrong, you get kicked out of school. So you got to be 100% confident. So what are you going to do with your interval? Make it enormous or make it tiny?
It's gonna be 70 degrees.
Make it enormous.
Well, you just got kicked out of
You just
school.
got kicked out of school. You're going to make it huge, right? So more confidence requires a larger interval. Right.
But you can only have a sample size of 1,999,900 milliliters.
Thank you.
You're welcome.
I was wondering.
I was wondering too.
Did you find inverse T at that point?
Yeah.
Is it like identical?
It's 1.5999961 whatever.
And what is it with